Okay, so in this lesson I am going to look at proving identity number 4 from my list of identities, trigonometric identities in our course. It's numbered 4. Cosine of A minus B is equal to cosine A times cosine B plus sine A sine B. That's for any angles A and B. So, a couple of things, bits of background information. You must be able to square a two-term expression. It's always going to be the square of the first plus double the first by the second plus the square of the second. You should be able to write the polar form of a point with modulus or and argument theta. If I have any point, with the modulus or and argument theta, for example, if this is my point, that means that distance is or, that angle is theta. This point can be written as or cosine theta, comma or sine theta. The cosine rule, the Cartesian distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. It's just the square of the run plus the square of the rise inside there. And the Pythagorean identity is for any angle, cosine squared of that angle plus sine squared of that angle is always equal to 1. So here's my proof. What I'm going to do is start by taking 2 points P and Q on the unit circle with arguments A and B respectively as shown. Remember, we're trying to prove this. And the proof is going to be, first of all, to write these points in polar form. Then we're going to express the distance between them in two ways. We're going to use the distance formula to find the distance between them. In fact, to find the square of the distance between them. And we're also going to use the cosine rule. Then we'll be using the transitive property of equations to come up with an expression, simplify everything, and we'll have our identity. So step 1, let's write these points in polar form. Note, if I just connect P here to the origin from P down here, it's telling me that has an argument of A. What does that mean? Well, it means that angle in there. I'll put it in blue. That angle is A. Okay, which means that P can be written as, well, note, or is just 1. It's a unit circle, so the radius is 1. So it's 1 cosine P, comma 1 sine P. Or sorry, sine A. 1 cosine A. The argument is A. 1 cosine A, comma 1 sine A. Okay, that's the polar form of the point P. If I look at Q, connect up the modulus here. Let me put it in red. And the argument here is B, that's given in there. So that argument there to Q, that's B in there. Well, Q can be written in polar form. Again, note the radius of the circle is 1, so Q's modulus is 1. It's going to be 1 cosine of B, comma 1 sine B. Also note the angle in between these two things. Well, it's going to be whatever A is, subtract whatever B is. Okay, and that's going to give me my cosine A minus B ultimately. So in order to prove this, the next thing I'm going to do is just construct a line segment connecting point P to point Q. And I'm going to think about the length of that line segment. Okay, I want to think about that distance. Let's just call it distance D here. Okay, using the distance formula, we can say that D squared is going to be equal to the change in X squared plus the change in Y squared. So it's going to be equal to cosine A subtract cosine B all squared plus the change in Y, the rise here will be sine A minus sine B. All squared. And I'm just going to square everything out there. This is where squaring a two-term expression comes in. It's always going to be the square of the first term, in this case cosine squared A, minus twice the first by the second, that's 2 cosine A cosine b plus the square of the second, which is cosine squared b. But I'm also adding the square of the second. I'll write it in underneath because just for space. So squaring the first, sine squared a, minus 2 sine a is sine b, and then we'll have a plus sine squared b here. So a couple of things to note in here. If I just kind of highlight these two terms, cosine squared a plus sine squared a, well, that's my Pythagorean identity. That has a value of 1. Cosine squared b plus sine squared b, that has a value of 1. So cosine squared plus sine squared a giving me a value of 1. Cosine squared b plus sine squared b giving me a value of 1. And then we've got minus, and I'm going to factor out a 2 from these two terms in here. So 2 is common, and minus 2 is common, so I'm factoring out a minus 2. And what I get is cosine a, cosine b, and plus sine a is sine b. So notice I'm factoring out a minus 2, so minus 2 times that, giving me this thing, minus 2 times the second term, giving me negative 2 sine a sine b. Okay, adding those two ones together gives me 2 minus 2 cosine a cosine b plus sine a sine b. Okay, and remember, that's the square of the distance between these 2 points. Okay, I'm just going to put that equation in my back pocket for a moment. Keep an eye on that. So it's just keeping an eye on that equation. So that's equation, we call it equation number 1. And my job now is to find a second equation using the cosine rule. So the cosine rule says the square of this side, d here, we put it down here, so using the cosine rule, which says the square of this side d squared, is going to equal to sum of the squares of the other two sides, that's 1 squared plus 1 squared, minus twice the product of the other two sides, that's 1 by 1, times cosine of the angle between those two other sides, that's a minus b. Okay, and just, tidying that up a bit, that's d squared equals 1 squared plus 1 squared, that's 2. 2 times 1 times 1, that's minus 2 cosine of a minus b. And there's my second equation. There's equation 2. So we have equation 1 saying that d squared is equal to this, and equation 2 saying that d squared is equal to this. And we are going to use something now called the transitive property of equations, which says if sum a is equal to b and a is equal to c, then b must be equal to c. So if d squared is equal to this right hand side and d squared is equal to this right hand side, then those two right hand sides must be equal. Okay. So what we're going to do is we're just going to equate equations 1 and 2. So from 1, the right hand side is 2, subtract 2 times cosine a cosine b plus sine a sine b, that's from the first equation, and that has to equal to the right hand side from the second equation, which will be 2 minus 2 cosine of a minus b. So just 2 more steps. We're going to subtract 2 from both sides, which will lead to cancellation there, subtracting 2 from both sides. And then I'm going to take what remains on both sides and I'm going to divide by negative 2. And what I'll get here is, well, dividing by negative 2 will cancel that. Multiplication by negative 2 cancel that on the right hand side, and we'll get cosine of a times cosine of b plus sine of a times sine of b, is all equal to cosine of A minus B, and that is what I was setting out to prove. So that's my end of proof. Quid extra demonstratum, that which was to be proven. That's the proof of identity 4. The proof of identity 5 relies on understanding identity 4. Okay, so practice that, go through it, make sure you follow all the steps. There's a lot of basic tools in here. If there's any kind of these things you don't understand, then you're in trouble with this proof, really. You've got to know those basic things, all of which you will have gone through before in class, of course. Okay, so that's the proof of identity number 4. You have to know it. It's one of your 9 mandatory trigonometric proofs.